This experiment is about the moon phases. This model only shows the relative positions of the Sun, Earth, and Moon. It does not show their relative sizes or distances from each other. The fact is, the Sun is about 109 times bigger than the Earth. Also, the Sun and Earth are far from each other. Even so, this model helps us observe how the Sun, Earth, and Moon move. This is Taiwan. This is the side of the moon that we can see from Taiwan. After 12 hours, this part of the Earth sees the same phase of the moon. After another 12 hours, Taiwan faces the moon, and we can only see a little change in the phase of the moon. One Earth rotation is equal to 1 day. On a given day, everyone on Earth sees the same phase of the moon. The next day, we only see a little change in the moon's phase. The Earth is tilted. This is the reason why there are different seasons. When the moon goes from one phase to the same phase, the Earth rotates about 30 times. This is one lunar month. Get a label and stick it on the side of the moon that faces the Earth. Let us observe the relative positions of the label and the Earth. Let us complete one moon revolution. Notice that the side of the moon with label always faces the Earth. From Earth, we always see the same side of the moon. This is because the time it takes for the moon to revolve around the Earth is the same time it takes for the moon to rotate on its axis. The Earth revolves around the Sun, the moon revolves around the Earth. Half of the moon is lighted by the Sun. But as the moon revolves around the Earth, our view of the bright part of the moon changes. This is why we see the phases of the moon. It takes 1 year for the Earth to completely revolve around the Sun. This experiment is about simulating the moon phases. We need a small styrofoam ball, big styrofoam ball, 2 skewers, 2 thumbtacks, and a parallel light source. Put the light source in one place. Get the styrofoam balls. The big one will be the Earth, and the small one will be the moon. Usually, a styrofoam ball has a line that goes through the center. Aim the tip of the skewer to this line and insert the skewer into the ball. Do the same for the other ball. The shadow produced in the ball will become more accurate if the skewer is close to the center. Use a thumbtack to mark the location of Taiwan on Earth. Position the Earth and Moon. Turn on the parallel light source. Get the Earth so that the light touches it. Put the palm of your hand behind the Earth. You should find the shadow on your palm. This means that the light is coming from there. At the start, the moon looks dark when viewed from Taiwan. This phase is called new moon. Rotate the Earth 3 times, which is equal to 3 days. The moon will revolve around the Earth at the same time. After 3 days, we see little light that looks like an eyebrow. This phase is called waxing crescent. The Earth will again rotate while the moon revolves around it. After about 7 days, half of the moon is bright. This phase is called first quarter. After about 5 days, the moon is more bright. This phase is called waxing gibbous. Rotate the Earth again. The moon is brightest on the 15th day of the lunar month. This phase is called full moon. After about 3 days, the moon is less bright. This phase is called waning gibbous. After about 5 days, even less of the moon is bright. This phase is called third quarter. After about 2 to 3 days, even less of the moon is bright. This phase is called waning crescent. Finally, after about 2 days, the moon is back to where it started. This completes the phases of the moon. The sun does not move. We see the moon phases because our view of the bright part of the moon changes.